We are going to begin with a topic on relationship and causality. Relationships, causality, prediction. Relationship, causality, prediction. Correlation and regression. Somebody should type, all of you type either correlation or regression in the chat. I need to be sure you are ready. Type correlation or type regression. Type correlation or type regression. I'm just going to count to those that will do it. Type correlation and regression. Now, you are about to do your research, and in your second year, you'll be doing a research. And research will require that. Sometimes they call it long essay, sometimes they call it project, sometimes you call it dissertation, sometimes you call it thesis. It is a research. It is a research. Sometimes it's for a company. You do a research for a company. Now, let's assume that you are about to do a research about the factors that can influence blood pressure of a person. What sort of things do you think will affect the blood pressure of an individual person? You can tell me. I mean, just mention one or type one. What are some factors that can influence a person's blood pressure? Stress. Abigail says stress. Diet. Dinah says diet. Palm. Olivia says pain. Olivia, I won't buy that.
Hello, sir.
Anita says age. Age is good. Okay. Financial distress is not good. It's still part of stress. Medication is true. Depression. Look, let's put it all together and call it other diseases. Exercise is good. Pregnancy is good. What is fats? That is fats. No, you're not really talking. So some will come again. Tell me something. Okay, say some. Tell me something that can affect blood pressure. Excellent, Pony. Genetics, heredity, very good. Okay. Family history is the same as genetics. Anita says, wait. Anxiety is all part of the stress. Barbara, anxiety is all part of the stress. Anyway, so all of these things can affect blood pressure. Now, so here, there is some sort of correlation there. There is some sort of correlation there. And we want to look at correlation, and then we'll look at regression in the process. So let's start with correlation. Now let's start with correlation. What is a correlation? It's just a relationship. Please write this down. Correlation is association. Regression is causality. Write it down. Correlation is association. Regression is causality. There's an exam question on it. Correlation is association. Regression is causality. Discuss. So, what is correlation? Correlation is an association. Now, who can give me another synonym for correlation? Who can give me another synonym for correlation? Another synonym for correlation. Type it there and let me see. Someone says lack of sleep. That is not a synonym for correlation. Similarity is not a synonym for correlation. What is the synonym for correlation? Which words are nearest to me? Don't Google it. Stop Googling. Stop chat GPT. It's not going to help you. Relationship. Relationship. What else? Association. Association. What else? Link. I love that, Anita. Okay, I love that. Connection. I love that, Barbara. Okay, connection. Interaction. Well, that's a little bit something. What is tie-in? Assembly. Come again. Okay. Linkage. Relation and interrelationship is the same. Good. There's a word I'm looking for. Come on. Interdependence. I love that. Kwame, I love that. Mutuality. Hey, Assembly, what have you eaten? Okay. Give us some word and then mutuality. Hey, okay. Correspondence. It's a bit okay. Correspondence. Okay. Parallel, no. Concurrent, no. Okay. People are saying things, so it's like you're thinking of, lexicographic statements that I don't even know. Association and then nexus. Nexus. All right. So now you guys will know that a correlation can be strong or it can be weak. A correlation can be strong. Let me give you an example. Now, the correlation between a brother and between cousins, which one is generally strong? Is it between cousins or between brother and brother? Which one? Or between brothers or between cousins? Which one is strong?
Brothers.
Yes, between brothers. Between brothers. Okay. And then the other one is relatively weak. So just take note that correlation can be strong, can be weak, but also correlation can be positive or negative. Okay. So in other words, on the positive side, you can have strong or weak. And then on the negative side, you can also have strong or weak. Let's take an example. What do you think is the correlation between consumption and income? Is it positive or negative, generally? Positive or negative between consumption and income? Raise your hand and tell me. But of course, if you, whatever answer you give, if you type it, is a lottery, unless you raise your hand. Solomon.
Yeah, so I think it's a positive correlation, please.
Why?
So because when your income is high, you consume more. But when your income is low, you consume less.
Very good. Very good. Generally speaking. Yeah. Generally speaking, that's true. Now, what is the correlation between quantity demanded and price? What is the correlation between quantity demanded and price? Barbara.
It's negative.
It's negative. Explain.
The higher the price, the less the quantity demanded.
Excellent. Very good. So you can have a correlation that is positive or negative, and then on the positive side, you can have strong positive or weak positive. And on the negative side, you can have strong negative and weak negative. Okay, now look on the screen. The relationship you are seeing on your screen right now, tell me, is that positive relationship or is negative relationship? Is that poor or net? The one on the screen. Sorry? It's positive. Okay. John has indicated that it's positive. Mary says it's positive. And what about the second one here?
Negative.
It's negative.
It's negative. Very good. You see, you can talk about it for hours, but you need a number. You need a number to represent a correlation to either be positive or negative. You need a number. So let's go get a number that will show that a relationship is positive or a relationship is negative. And that is known as the correlation coefficient. Sometimes it's known as Pearson's product moment correlation coefficient. Okay. This is assuming that the data is ratio. I'm sure you remember nominal, ordinal, interval, ratio. So we need something, we need a number, and this number is a percentage. So you can have a percentage that is up to negative 100%. And then you can have a percentage up to positive 100%. So the correlation coefficient is a statistic, just like mean is a statistic, just like median is a statistic. Now, this one is also a statistic. That tells you the strength of the relationship. Okay. Now, looking at everything you are seeing on your screen right now, I want to ask you a question. Okay, everything you're seeing on your screen, I want to ask you a question. Which of these correlation I'm about to write is a strong correlation? Raise your hand and tell me. Which one is a strong correlation? Which one is a strong correlation? You gotta be incredibly smart and follow to be able to talk. Which one is a strong correlation? You gotta raise your hand because I need you to justify. Wama.
Please, it's negative 0.8 because it's an absolute.
Why?
Because of the absolute.
Exactly. So when you have a negative value, don't say that because it's negative, that makes it bad. No, 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 no. Don't see negative here as bad and positive here as good. No, no, no. The negative is just showing the direction of the relationship. And if it is big, always you focus on the absolute value. This is an important point because in the exam, I will give you a complete correlation matrix and I'll ask you a series of questions. Okay. Now, so a correlation coefficient, which is between -1. Now, when it is equal to 1, what does a correlation represent? It starts with P. When the correlation is equal to 1, either positive or negative, when it is 1, it represents what kind of correlation? What kind of correlation? That kind of correlation it starts with the word P, with the letter P. What kind of correlation is that? Raise your hand and talk if you are ever talking here. Okay. What kind of correlation are we talking about? If the correlation is 1, exactly 1, the correlation is known as perfect correlation. Okay, perfect correlation. Now, if the correlation is exactly 0, exactly 0, what kind of correlation is that? Richard?
No correlation.
Exactly, no correlation, no correlation. Okay. All right, so now let's continue because we've got some interesting things to look at today. So if you look at the screen, I'm going to show you, point some things, and your job is to tell me whether the relationship between the X variable and the Y variable, you're going to tell me the relationship there as depicted by the scatter plot. This is a scatter plot, but it has a trend line or a trend curve passing through it. So looking at the first one I have ticked here, it is exhibiting what kind of relationship? You can tell us. What kind of, I have series of this, and always raise your hand if you're ever talking. Okay. I've asked series of this in an exam to see how you indicate. What kind of relationship is that? Yes, John.
I think it's a positive relationship.
It is a positive relationship. Very good. Very good. John, I have 2 marks for you. Solomon, please take note. You're a crasher. Take note. Okay, I have 2 marks for John. Now, what kind of correlation is the one below here? What kind of correlation is that, Solomon?
Please, it's a negative correlation.
It is a negative correlation. There's no doubt about that. Now, what kind of correlation is the one on the right here? You raise your hand, you tell me. What kind of correlation is that? Yeah.
Negative.
Okay. Yeah, that is wrong. That is wrong. Let's go to Barbara.
Decreasing correlation.
Okay, Barbara, that is wrong. Let's go to another person. What kind of correlation is on this side here? What sort of correlation is this depicting? Marvin.
Not non-linear correlation.
Sorry?
Non-linear.
What kind of non-linear? There are so many of them. What kind of non-linear? Come back again. Who can tell me the type of non-linear? Okay. What kind of relationship is here? What kind of relationship is there? Okay. So the relationship is quadratic. Okay. It is quadratic. It is quadratic. Now let's go to the one on the bottom section here. What sort of relationship is this last one? I will not let you think too much. It's a logistic curve. It's a logistic relationship. So you should be able to know any kind of scatter plot diagram. You should be able to know the sort of relationship that is embedded. Okay. Now, let's get deeper. Let's get really deeper now. That is correlation, but that is not regression. Now, earlier on, I told you the difference between correlation and regression. Who can raise a hand and tell us? Earlier on, I told you the link between the two roots.
Yes, please. You said correlation is association and regression is causality.
Very good. Very good. What does that mean? What does that mean? Now, let me ask you a question. Correlation is a subset of regression. Regression is a subset of correlation. Which one is true? Which one is true? Correlation is a subset of regression. Regression is a subset of correlation. Which one? If you guess, I'll give you -100. So you shouldn't guess. You got to explain what you mean. Yes, Ruth.
Yes, please. I think that regression is a subset of correlation because in regression, which is a causality, there's still a relationship, which is an association.
No, it's the other way around. Correlation is rather a subset of regression. Regression is bigger. Inside regression, there can be correlation. You see, there can be a correlation when there is no causality. There can be a correlation when there is no causality. But once there is a causality, there is a correlation. Let's take an example. Okay. For example, let's assume that during Christmas, you saw that demand for food stuff at the market, at the market square, the demand for foodstuffs increases. It increases. So market women get a lot of money. And you would think also that because they are getting money and demand is rising and people are buying things, you would think that people will be cooking at home and therefore will not be going to restaurants to eat. And yet we know that during Christmas period too, demand for restaurant food also increases. So whilst there is an increase in the demand for foodstuffs at the market, there is also an increase. There's a correlation between the two. Whilst this is rising, this is rising. And when this is falling, this is falling. And therefore, you'll be tempted to think that it is one of it that is causing the other. But no. None of it is being caused by the other, but rather something else outside both of them is causing them. And that is the season at hand. So there is a correlation between these two, demand for foodstuff, demand for restaurant food, and yet there is no causality. Ruth, are you following?
Yes, sir.
However, you can have a situation where there is an increase in the price of restaurant food, which then reduces the quantity demanded of that restaurant food. So in this context, the two of them are correlated, negatively, of course, because rising price leads to falling quantity demanded of restaurant food. And these are correlated, but also one is causing the other. It is a rise in the price of the food that leads to the fall in the quantity demanded. So this is regression. There is causality, but also behind the scenes, there's a correlation, a negative correlation. Guys, it's important you understand what I've just explained. And that is the meaning of correlation does not imply causation or causality. Correlation does not imply causation or causality. Take note, it is critical. It is important. It is critical. It is important. It's critical. It's important. Because you have a question on that. You don't understand? Yes. So now we are going to look at regression, which is a step further beyond correlation. Two things can be correlated, but they are not, they are not causing each other. Okay? They are not causing each other. I always use the example of the gong beater. The gong beater does boom, 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 every Monday. And in the afternoon, there's always rain. every Monday this man does that, there is rain. What are you likely to conclude? What are you likely to conclude? Likely. What would you conclude?
The day he doesn't show up, it won't rain.
Yeah, but what are you likely to conclude?
That because he
You are
beats
likely. Sorry.
You see why I say it's good to raise hands? You see why? Mm-hmm. What are you likely to conclude? Yes, Araba.
It's likely to conclude that the Gongong beater has the power to call down rain.
Yes, but it may be just mere coincidence. That's it. It may be mere coincidence. So you cannot ascribe causality, but you can ascribe correlation. Causality is stronger. Regression is stronger. So what is regression? So regression is not just an association or a relationship. No. Regression is a causal relationship. Take note. Regression is a causal relationship. It's a causation, it's a causal relationship between two or more variables. Now, one of the things you should notice that the variable that is causing, the causal agent, the variable that is causing is different from the variable that is receiving. Okay, it's different from the variable. Now, the variable that is causing, it has a name. And the variable that is receiving also has a name. Now, I want to write it in a certain way so that it will match the mathematics we're about to do very soon. So the recipient, okay, has a name, and then the cause also has a name. Okay. So who can tell me a name for the recipient? What is one name for the recipient? The variable that is being influenced, the variable that is being impacted on. What is the name for that, Marvin?
Dependent variable.
And what is this corresponding causal one?
An independent variable.
Very good. So guys, take note. The first is that the recipient is dependent variable, and then the cause is independent variable. What is another name for the dependent variable? And another name for the corresponding independent variable? Who can give me another name for the dependent and then the independent? What's another name? Let me see. So the dependent variable is also called outcome variable. Okay, and the independent variable is predictor variable. The dependent variable is also called explained. I've set questions on this. And this corresponding dependent variable is known as explanatory. The dependent variable is known as regressand. And the independent variable is known as regressor. Yes, Ruth.
Please, can you go over the differences you are giving again?
Which one didn't you understand? You can say I should go over all of them.
I heard you talk about explanatory and another one, but I can't tell which one is which.
The explained is the dependent. You can see it here. This explained is the same as the dependent. And then the explanatory is the same as independent. Okay, so there are some kinds of regression. At your level, we are just going to look at 3 types of regression, basically 3 types. But there are about 18 different types of regression. Okay, but we're going to look at 3 types. The first one is a simple regression. The second one is a multiple regression. And the third one is dummy variable regression. Let's try to understand all of them. Oh, by the way, when you look at the following, who can tell me the dependent variable and then the independent variable? Let's take the first one. Suppose we are looking at the education's effect on income. That is the impact of education on income. Which is the dependent and which is the independent? Yes, Richard.
The independent is education, and then the dependent is income.
Correct. Impact of hours of study on students' grade. Which one is a dependent? Which is independent? All right.
Grade depends on the hours of study.
Which one is a dependent?
Grade.
Good. So class, we give her about 2 marks for me. Okay. Solomon, are you with me?
Yes, Doc.
Are you taking note of the marks I'm giving?
Yes.
I don't give marks when a person answers a question. I give marks by looking at the consistency in which the person is patronizing. Okay. All right. And this will go into the continuous assessment, guaranteed. Some of you, this is the only one that will help you to push up the grade you wanted. Okay. Now, we'll come back to this simple, multiple, and all of that. Okay. And the only way to explain it is take a model. I want you to put this down. What is a model? A model is a representation of reality. Write it down. A model is a representation of reality. A model is just like an image. So when you take a selfie and you're looking at your selfie, that selfie is a model because it's representing you, the reality. When God looks at us, we are his model. He is a real because we are representation of him. A model is a representation of reality. Now, what you are seeing on the screen here is a model. This is a model that is representing something that is real. And this is a simple regression. Why? Because it has a dependent variable and it has an independent variable. Now, looking at all the variables here, some of them are Greek letters, some of them are English letters. Which variable do you think is the dependent variable? Who can tell us? Barbara.
YI.
YI is the dependent variable. And still on you, Barbara. Which one is the independent?
Alpha.
Okay. I thought you were going to say X. Okay. Then I would have said that you cracked it. But that clearly shows that you were guessing with the first one, probably. Okay. Because if this one had I, the only option of those that have I are this and that. So I was expecting like you to say one of them. So guys, the independent variable is just Xi. And because and here's a clue. The reason why we call it simple. Why? Simple because the independent variable is 1. That's it. Write it down. The dependent variable is a number. It's a number. So you can have Y variables, Y numbers, 2, 9, 6, and 7. And then you can have X variables, which is 13, okay, 15, you got 19 or 21. So you got some variables for X, you got some variable for Y. Y is the dependent or the regressand, and X is the independent. Write it down. X is the independent, which is the regressor. Now, what is this model saying? Now, the reason why it's this simple is because the independent variable is 1. What is it saying? It is saying that the X variable influences the Y variable. That's it. The X variable influences, impacts on, affects the, okay, or the Y variable is dependent on, is conditioned on the X variable. Now, the question becomes, what are the alphas? Write it down. What are the alphas and the betas? The alpha is not so important than the beta, so let me talk about the beta first. Now, we said that the X affects the Y. The Y depends on the X. So by how much does the X affect the Y? You tell me that your weight will affect your blood pressure. By how much? By how much? By how much does the X affect the Y? This is what the beta parameter will tell you. So the beta parameter, guys, you will write a model in the exam and explain it. So the beta parameter tells you by how much the independent factor affects the dependent variable. In artificial intelligence and machine learning, data science, they normally will use the word features for the X variable and target for the Y variable. So by how much does another complex way of saying it is that what is the marginal effect of X on Y? So B measures the marginal effect. So if I take the partial derivative, of Y with respect to the partial derivative of X, I should get the beta parameter. You write it down. It will be useful one day. This is master's degree. So sometimes when you see some of these things, don't think they are Hebrew. Sometimes some of these things are not Hebrew. They are just masters. They are just showcasing your mental agility. Your mental gymnastics. Okay, so now you understand the beta. Now, even if we go to multiple regression, where the X's are now many, the beta will also be many. But it will still mean the same thing. It is the marginal effect of the X on the Y. That's better. Okay, what about the alpha? The alpha is cosmetic. It's just for beautification. The alpha is what is known as the constant or the intercept. The alpha is just telling you if there is no independent factor or variable affecting the dependent variable, then what is the dependent variable really going to depend on? Okay, so the alpha, right, is alpha has no economic interpretation. Alpha has no economic meaning except during prediction. Alpha is actually not useful except during prediction. Alpha is only important during prediction. And remember, we'll do prediction in 2 weeks' time. So that's when you really understand the alpha. Okay. Now we are left with the U. The most important one is the UI. The UI is sometimes represented by epsilon I, or sometimes represented by EI. It's the same thing. Write it down. It has got 11 different names. Let's say 10 different names. Each one of you is going to give me one name for 1 mark. So you raise your hand. What name can we give to this UI? I mean, normally you either know it or you do that. Yes, Marvin. Sorry?
No.
It's called error term. Not just error, but error term. So at the first name, you check my past question. I've asked you this question already. So the UI is called error term. Very good. Marvin. Marvin, you have 2 marks. Not because of this answer you've given, but you have 2 marks. Who can give me another name for this error term? What is another name for the error term? Yes, winner.
Residual.
Residual, very good.
Okay.
In case you are here and you don't know these things, write them down. Residual. Okay, residual. That's 1 mark for me. Another one, Araba. Those of you who are Googling, stop Googling. It's not helping you. Yes, Araba.
Disturbance term.
Disturbance. Are you sure it came from your head or you just went to Google?
No, please.
Which one is a no, please? Which one is a no, please, Araba? Something tells me you Googled the thing.
No, please. I didn't Google.
Okay. Yes, who can give me another name? Another name for the error time. Come on. We're going to look at what is the use of the error time. It's the most important aspect of assessing this model, of bringing this model to life. Oh, there's another word which is known as stochastic noise. Sometimes it's even called noise term. It's stochastic error. Okay. Sometimes it's known as the noisy term or random noise. Random noise. Sometimes it's known as the idiosyncratic error.
Is it the same as disturbance term?
Yes, it has been said above there. Someone has said that above. Idiosyncratic error. Sometimes it's known as white noise. Okay. White noise, especially in time series, known as white noise. There's a bigger word which is known as unobserved heterogeneity. Unobserved heterogeneity. Unobserved heterogeneity. All right. So these are some names for the error term. What is that? What is that? The error term tells you all other factors that could affect the dependent variable but have not been captured in this model. That's the error term. All other factors that could affect the dependent variable but have not been captured in this model. Write it down. And why do you call it error? It is an error because you don't know them. You don't know them, but they can affect the dependent variable. Meanwhile, you are claiming that the only thing that can affect the dependent variable is the x. Yeah. But there are other unseen, unobserved. That's why the word unobserved comes in. They are unseen. They are unobserved. In fact, sometimes we use words like latent factors. You know, they are unseen, they are unobserved, they are latent. Okay? And these factors are not seen, and yet they are behind the scenes affecting the relationship between the x and the y, affecting the y variable. And so, what would you want to do with these errors? Would you want to increase them or reduce them? Would you want to increase or reduce? Abba.
You want to reduce them.
Yes. So please note that the essence of the entire regression is to reduce these errors. That is the essence. Cut it down. Okay. Now, but how do you cut it down? Well, you're going to see very soon that the errors are above and below the line. Okay. So now you understand a simple regression. Now, the difference between a simple regression and a multiple regression is simple. The difference is that a multiple regression has got many of the x's and then many of the betas. So here, the independent variables are how many? How many are the independent variables in this multiple regression? How many? Five. Now watch this. I can write another regression model. Okay, I can write another regression model like yi, and then have beta naught, okay, plus beta 1, x1, plus beta 2, d1, plus beta 3, and d2, plus beta 4, x2. So you can see that now I've changed the x's to some of the values to d. Why? These d's are no longer metric. You see, the x's here are numbers, data you have collected, data you collected. For example, we are going to be using the Burkutu data set. So look at that data set. You see that some of them are, some of the columns are numbers, but some of the columns are also English words like religion, occupation, and location. You can open that Excel, by the way. You should open it now. Now, these factors are not numbers. If you can remember the data types, are they numerical or categorical? Are they numerical or they are categorical? Should I show you? Maybe when I show you, you get it. This is them. So if you look here, the quantity demanded is numbers. The price is numbers. The complement price are numbers. The income are numbers. But the location, occupation, and religion, they are not numbers. What are they?
Categorical.
They are categorical. What type of categorical do you think location is? Is it nominal or ordinal? Is it nominal or ordinal? It's nominal. What about occupation?
Nominal.
Nominal.
What about religion?
Nominal.
So you see, you learn that thing well. So you can actually clearly say what it is. Now, so these are called categorical, nominal, but the name we use for them in regression is called dummy variables. Dummy variables. And that is why you can see that when I wrote one of them, I used the term D. So I use the term beta 1 or D1, but when I say beta 2 X1, so you can see that beta 2 here is for X1, and X1 is numerical, but the D1 is categorical. Now these D1 variables are called dummies. Write it down, dummies. Now, what does the word dummy bring to your mind? Dummy brings to your mind what word? When he says this guy is sorry?
Categorical.
Yeah, but what does it carry? The idea of what? How does the idea of dummy compare with the idea of, dynamic? When you say somebody, what is a dummy?
So is it to say it's a placeholder?
Yeah, when something is dynamic, what is it?
It can change with time. I mean, it can
change with time.
It's a variable.
Its opposite is what?
Static.
So if it is static, what does the idea of dummy carry? When your baby is having something, chobi, we normally call it. Sorry.
Replica.
Yeah, but the idea, the word dummy carries the idea of what? Something that is what? Is it dynamic or static?
Static.
It's static. Dummy carries the idea of stagnant. The word static, by the way, comes from the word statue. You know statue? Statue. The statue of Nanado. You know the statue of Nanado. Well, that statue doesn't move. It's not dynamic, it's static. And it is from this that the word law or statutory comes from. Because something that is law doesn't change. Principles change, but laws don't change. It's static. You see, they all carry the word S in front of static, statute, statutory, static. So that is it. So a dummy variable is a variable that is not changing. And a dynamic or numeric variable is a variable that is changing. Lovely. Excellent. So what is the difference between a simple regression and a multiple regression? A simple regression has gotten only one independent variable. And then a multiple regression has many independent variables. But the last one is the dummy variable regression. The dummy variable regression, the difference between that and a multiple regression is that the dummy variable regression has gotten both independent numbers and independent dummies. So some of them are dynamic, some of them are dummies or categorical. Okay. Write it down, you forget. Write it down, your brain will deceive you. Okay, so now these are theories. We are learning a bit of theory before we come to the practicals. So I've given you the general model of writing a multiple regression because you see the way it is. You write all of this x1, x2, up to x100, x101, If there are many, you just use this to summarize them. You just use this to summarize. So you just say that take a sum of all the x's after you have taken the product of the x's and the betas. Each beta is multiplying an x. So as long as you are multiplying it, then you are taking the sum of it. Finish. Okay. Everything has been explained as we have already gone through. So let's go to another kind of regression. This is another kind of regression where this very regression is not a usual regression. This is nonlinear regression. Nonlinear. Nonlinear means that it is not a straight line. It's not a line. The fact that this thing has got a square here means that it is not linear. You see, this one here is linear, but this one is not linear. And such kind of regression are polynomial or quadratic. Polynomial or quadratic. You saw a graph of that previously. Polynomial regression are nonlinear regression because of the quadratic. A quadratic curve, if you can remember, a quadratic curve is like an ogive. Okay? Either is this or that. It's like an ogive. Remember the secondary school that you went through? You've forgotten. You've forgotten all the mambo jumbos you did. Tan theta, cos theta, pi r squared, the parts of a grasshopper. Things you don't even use in real life. You learn things, so, and you're still learning things. So if you look at it, it is telling you the fact that this thing is going up, it gets to a point, it comes down, means that it's not straight line. That's what it means. You see, this is a straight line. That is a straight line. This 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 is a straight line. But this one is not a straight line because it goes up, it comes down, and therefore it's not a straight line. It's a curve. It's a curve. And when it is a curve, you represent it using polynomials. Good. And then this is an example of a logistic regression. A logistic regression, the dependent variable is given, the focus is on the dependent variable. So the dependent variable takes only two values. Only two values. They're actually no values. For example, yes or no. You can just, yes or no, is it nominal or ordinal? Yes or no. Is it nominal or ordinal?
Nominal.
Nominal.
And because it's nominal, you can code it. You can just say, let yes be 0 and then no be 1. The fact that the dependent variable, which is always numbers in a normal regression, but it changes to become just yes or no, or something that is male or female, or anything else, okay, that dependent variable cannot be modeled using a regression, but you can model it using something known as logistic. And this is a typical example of binary classifications. Okay, don't worry, we will not do logistic at all. Now, let's come to real life. Everything we have been talking about is X, Y, X, Y. Oh, is too complicated. Let's make it simple. Leonardo da Vinci says that simplicity is the ultimate sophistication. Write it down. Simplicity is the ultimate sophistication. If you cannot explain it to a 7-year-old child, Einstein says you don't understand. So let's calm down. Leonardo will say, calm down, calm down, calm down. Let's take a real life situation. Your salary. Your salary is your wage. Your wage. You all agree with me, and I'm going to give a lot of marks here, by the way. You all agree with me that your salary or your wage is affected by education. It is also affected by your experience, another independent variable. It is affected by your position on the job, and it's also affected by your ability that you bring to the job. Now, for 1 mark, tell me what other factors can affect your wage but have not been captured here. These factors have been captured in the error term here, but you can't see it. But tell me, what other factors? And please don't tell me factors that are irrelevant. Don't worry, I will determine whether your factor is relevant or not. but there are factors that can affect your wage but have not been captured yet. So let's start. Who can give me the first factor? Ayima, Jerry.
Prof, duration.
Duration. No. Yima, Ajewa.
Emma. Prof,
Emma.
qualification.
Qualification is inside your education. So no.
Yes.
Frederica.
Working hours.
Working hours is all part of the reason why we are here. Okay. So, but there's something else you should go and think about and come inside working hours. Let's go to Brigitta.
Your competencies.
Competencies are all part of your ability here. So no. John, please lower your hand when I say no. Sorry?
Performance.
Performance, everything here is performance. So no. Patience. It's not easy.
Prof, I think occupation and the job you are going to do, the occupation, the type of job, because some companies tend to, yes, some companies pay more. Yes,
the type
please.
of job is good. It's called RICS or type of job. Very good.
Yes,
so you're the first person to crack it. That is 2 marks for you. Okay, not 1, 2. Let's go to, please mute yourself. I've not called you. Don't say me. Okay. So that the thing becomes Makola line. Lulu.
Sir, please, the job demand.
No, it's not the job demand. Let's go to Grace.
And please, can you also talk about the company's policies?
No, it's all part of the type of job. Let's go to Ruth.
Yes, that is how sought after you are.
How sought is part of your ability. So no. There are three bits that haven't come at all. Pony.
Say overtime.
Overtime.
Pony, overtime. 2 marks for you, Pony. Okay, 2 marks.
So say I said it
Please
first.
don't say me. Did I call you?
Then say, can I mention another one?
Masa, go and come back later. You have given me the thing, you want to throw it away. What shows that what you're about to say is correct? Masa, sit in your corner. Let's finish. Felix.
Please, can I ask a question?
Yeah, go ahead.
So, in regards to the overtime, isn't it part of the ability? Because if you're able to work more, then you might be able to get more pay.
No.
So
the ability here we are talking about is skills, specific skills you have. You know, in knowledge, competencies, proficiency, mastery, expertise. That's what we are talking about, the ability. Okay. But over time is actually stretching yourself with time. It's connected to time. It's a physical work, not the ability which is mental work. So yes, over time will lead to an increase in your salary. And we know that in the literature. These are all documented. I know it all. So that's why. Let's go to Terry.
So you called me.
Yes,
So
Felix.
Yes. Cost of living.
No. Cost of living will affect everybody. So it's not special related to an individual. Let's go to Terrence.
Yes, sir. Responsibility. No.
Out. See, I know these things. I've done this for 14 years. So I know these things. So when I say no, just get to me. Some of you will not lower your hands. Somewhat back and forth.
Is the country or location?
Excellent. I'll buy that location.
I wanted
I'll buy
to say
that.
this.
Samuel, that is good for 2 months because if you are in London, you are paid more than if you are in Leicester. So location plays a strong role. Ebenezer.
So also the way you're able to negotiate can also affect your...
That is part of ability, okay? That is part of ability. Now let's go to Doris. See, her hand was up. She doesn't even know what she's talking about.
Please, can I say
your hands.
Allowance? Allowances.
Allowances.
Yes.
It's all part of your salary. It's all part of the salary. All right, guys, that's it for now. Let's go to the next one.
Demand
Now,
and
let's
supply
start
of
it.
labor.
Dry your hands. Dry your hands. And if you have a noisy background, don't be mean to yourself until you're called. Now, let's take another one. The blood pressure of a person is affected by the age of the person. It is affected by the weight of the person. It is affected by the stress of the person. Nobody should mention broken heart. It's affected by the exercise the person does, the smoking status of the person, the body mass index of the person. But of course, the other factors that should have been included but haven't been captured here. These are all inside the error term. Now, for 2 marks, you're going to tell me relevant factor. And I don't want more than 3 factors. Okay? Once I get my 3 factors, then we are done. So let's start with Dinah.
Genetics.
Excellent. That is 2 marks. Okay. Dinah, that's good. Let's go to Jonathan Nyote.
Lifestyle.
That is out. No, I will not buy that. You see, anything that is not measurable is difficult. If you check these things on your screen, you can measure them. How do you measure lifestyle? It's too broad. You can't buy that. Bridget.
Yes, sir. Eating habit.
Eating habit. You have to be specific, else I will not give you this thing. Be specific here.
Healthy eating habit.
No. You have to be specific here. One last chance.
Sir, eating late at night.
No. See, you are looking at the thing, but the word is diet. Diet.
Okay.
Diet. And by the way, nobody should mention anything that enters your body. So whether it's food, whether it's alcohol, whether it's medicine, all of them, let's put it all together as part of diet so that we don't have complications. I need 2 more. Ebenezer.
So hormonal changes.
Hormonal changes, no. Let's go to Araba.
Family history.
Somebody has mentioned genetics, didn't you hear? Let's go to Pony.
Pregnancy, sir.
Pregnancy is good. 2 marks. Very good. Okay. Let's go. See, when the thing is good, it's good. It's non-debatable. Let's go to one last one. That one is tough. Body patience.
Prof, environmental factors. Example, exposure to cold.
No.
I think.
Now let's go to Lawrence.
Kidney function.
There's a way you want to put all together. That way I can give it to you. Put it all together.
Failure.
Sorry?
Comorbidities.
Is it Lawrence who is talking or somebody else? Lawrence.
Yes, sir.
Put it all together. It's because once you mention kidney function, somebody's going to mention heart function. Another is going to mention, stomach function.
Okay, sir. Alcohol consumption.
No. I'm giving you one last chance. If you don't get it, I'll take it out of you.
Please, can I help Lawrence?
My dear, we don't need your help. We don't need your help now. The time will come.
Oh, sir, I've risen my hand.
Masa, Tobo. Go and eat. Lawrence, your time is up. That's all. Okay, let's go to Madugu.
The medical conditions.
Exactly. Any medical condition can also bring about blood pressure, like diabetes, like hypertension, all of the other possible medical conditions can also bring about. So we call it other diseases. Fantastic. That's it. We're done. I've got a 3. Now let's go to the third one. The quantity demanded of a commodity is affected by the price. We all know that. It's also affected by the income of the person or the type of the income of the person. That can lead to a higher or a lower quantity demanded, dependent on whether the good is a normal good or an inferior good. It can also be affected by the price of substitute, PSI, price of substitute. Quantity demand can be affected by advertisement. Okay, so sometimes when you advertise, then the demand will increase. It can also be affected by the price of complements. The price of complements. It can even be affected by population. Population. Nobody should mention taste and preferences. I don't want you to go there. And I always think about whether the thing can be measured. If it cannot be measured, behavior, lifestyle, those things are not important. So let's get 3 more and 6 marks now. Let's see who is starting. Winner.
The season.
Seasonality. Excellent. 2 marks. Seasonality. Weather. All of that. That is good for 2 marks. So that was for winner. That was for winner. Let's winner, lower your hands. We're done with it. Okay. Let's go to Paula Dote.
So I think government policies.
Excellent.
Taxes.
Government policy related to taxes or subsidies can also bring about quantity demanded going up or down. Fantastic. That's 2 marks for you, Paul. Let's go to Mary Ninson.
Please, location.
Location is also true. Location can affect the quantity demanded. For example, the demand for a certain commodity will be more if the location is urban or if it is rural. So that is very, very true. The 3 is done. I know there are more, but the 3 is done. But again, if you check my past question, I always ask you these sort of questions. So, but the one I will ask you under exam condition is not going to be the same as this. So you should be able to think through. You should be able to think through to be able to know exactly what is causing all of this. Now, let's look at this last one and the first bullet. Compare the first bullet with the last bullet. Now, if you look at the first one and the last one, there are differences. There are 2 main differences. The first bullet here is called specified regression model. Take note and write it down. Specified regression model. Linear regression model. Specified regression model. The last one here is similar to the first one. There is something. It is called estimated regression equation. Estimated regression equation. So I want you to carefully look at the specified regression model. Write it down in case you don't know the name. And then look carefully at the estimated regression equation. Look hard. There are 2 main differences you have to tell me. If you tell me 1, you get 0. If you tell me the 2, you get all the 2 marks. There are 2 main differences between the specified regression model that you see above here, and then the estimated regression equation that you see down here. Look hard. This is where intelligence comes to the fore. Marvel.
The alpha and beta have values.
Marvin, are you done? Are you done, Marvin?
Yes.
Okay.
Yes, please.
All right. So that is not all. So that is out. Let's go to the next person. Marvin, please, I asked you, are you done? You say yes. So don't continue again. Let's go to another person. Solomon Assembly.
Yes, sir. So, sir, please, one, there is no disturbance term or error term. And then
don't say
2.
1. Mention the name.
Okay, there's no error term there.
In which one? Which of them things? Because I mentioned their names and I told you to write it down.
So with the specified regression model. Yes, and then also in terms of
with a specified regression model, what?
One there is no
with a specified regression model. You're talking about this specified regression model, Abi?
Yes, Prof. Let me come back. Don't let me come back again.
Yeah, you should come back because you weren't really paying much attention. So you should come back. See, I'm very, very particular. That's why I say write everything. Let's go to the next person, which is Ruth.
Yes, sir. So with the specified regression model, that one doesn't have the alpha in it, but it has the error term at the end. Comparing it to the estimated regression model, that one also doesn't have the alpha, and that one doesn't have the error term. So the
That's wrong.
difference is that
That's wrong. It's okay. It's okay. I mean, the fact that you are struggling means that you are trying hard. Okay. Let's go to another person. Let's go to Richard Nyako.
Yes, Doc. So with the specified regression model, the error term is available. I mean, its step is present, but the estimated, you don't have the error term. That's number one. And then number two, with the specified regression model, the coefficient, the alpha has been, the alpha is there, and then the rest of the coefficients. But when you come to the estimated, it's been changed to numbers. So the coefficients have been replaced with numbers.
This is called wisdom at its zenith. If you were in a class, I would have given you $50. Seriously. Okay. So that's the wisdom. That's analytical answer. Very, very smart. 2 marks for that. Okay. Class rep, take note of that. Okay. And again, if you check past question, I've asked you this question multiple times. Okay? And even though we've said it today, you see that some people still. So the specified regression model has an error term and beta parameters. The estimated regression equation has no error term, but has numerical coefficients. It has numerical coefficients. Here, it has beta parameters. No numbers. But here, it has numerical coefficient. You should know the difference. One is a specified regression model. The other is estimated regression equation. We'll come and see the processes, the stage of moving the whole model to the equation here. That whole process is what is known as regression analysis. That's what's known as regression analysis. Now, in order to do regression, certain things must be in place. Okay, we call them assumptions. Okay, let's go. We call them assumptions. So I'm going to let you note these assumptions because I do ask sometimes about 2 of them every time. And you should know each one, understand it. The first one is that, oh, by the way, what are assumptions? Before you can undertake regression, you must have some assumptions. What are assumptions? Simple. Assumptions are certain things that must be in place before certain things can work. If you write it like this, you will always appreciate regression. Assumptions are certain things that got to do in place before certain things can work. Now, suppose I say that the University of Ghana Business School is running. Then it means that what? I've already assumed that what? If I say the University of Ghana Business School is running, I've already assumed that what? Students are there, lecturers are there, the markets are available, the computers are there, the building is there. So certain things got to be in place before certain things will work. The same thing for regression to be done. Regression is just a technique like ANOVA. I've done ANOVA with you, right? Yeah. So for certain things to work, certain things must be in place. So the first assumption is linearity. That is the relationship between the dependent variable and the independent variable must be linear. In other words, there must be a linear connection. If you go up, I go up. Or if you go up, I come down. It must be constant. And that is linear. So the first one is that there must be linearity. The second one is that there must be normality. Normality of the errors. Normality of the errors. normality of the errors. I normally repeat things 3 times for a reason. What does that mean? It means that the errors we've been talking about all this while, the stochastic noise, the random noise, all of those terms, the errors must be normally distributed. What does that mean? It means that when you average the errors, when you take every error for every individual observation, okay? When I say individual observation, suppose you have Y here. Okay, let me not use Y. Let me be practical. Suppose you have the wages, and then you have experience here. Your wage is 2,000. Okay, your experience is 4 years. Your wage is 6,000. Your experience is 5 years. Your wage is 8,000. Your experience is 7 years. So you can see that here the dependent variable has got numbers. The independent variable has got numbers. Okay. Now, the dependent variable is the one you are trying to influence. This is the actual variable. Now you go and do some regression analysis and you will come out with a predicted variable. So you will have predicted values for W, okay, which is different from the one you have for the actual W. Okay, so let's say that the predicted here is 3 instead of the 2. This one, the predicted here was the same 6. This one, the predicted here was rather -3. Okay. Now, once you've gotten this value, these are called, oh, sorry, the predicted here is rather, let's say, 11. So now, you take each one of them, okay? You find the error. The error is going to be the difference between the W minus the W predicted. So you take the actual one minus the predicted one, you get -1 here. You take the 6 minus the 6, you get 0. You take this one minus this, you get -3. Okay. You add all of them together, the mean, they should be 0. That's what it's saying. Okay. So this assumption is saying that for you to have a proper regression, the mean of the error term should be 0. That's what it means. The mean of the error term should be 0. The mean should be 0. The mean is 0. So sometimes we use this word that the error term should be normally distributed with a 0 mean and a constant variance. I'll come to this one with a 0 mean and a constant. This IID means that the errors should be independently and identically distributed. Don't worry, go and Google it. Should be independently and identically distributed with a 0 mean, normally distributed, normally. And I've explained normality many times here. Normality is when majority are in the center. For example, if you look at most of you, your grade is going to be normally distributed. Some of you are going to, few of you will get A, few of you will get F, majority will be in the middle. It's not what you wish. It is what it is. Okay? You just have to know where you will be. But the truth of the matter is that, you might get like 20% getting A, 20% getting F, and then the rest will be in the middle. You decide where you will be. Now, most of the time that is the case. Sometimes some class can be so smart that things will change. That's okay. But normality simply means that majority are within the center. And if they are within the center, then the error of it will be 0. That's what this assumption is. Then there's another one, a very long one called homoscedasticity. Homoscedasticity. It's a very, very powerful word. It simply means that the variance, you see, anytime we talk about the mean, we also talk about the deviation from the mean. The mean is the center. Write it down, write it down. The mean is the center. The deviation from the mean is the variance. Sometimes the square root of this variance is called the standard deviation. The square root of this variance is the standard deviation. So if I take the square root of the variance, I'll get the standard deviation. Now, the mean is what we are saying that it should be normally distributed with a 0 mean. It should be 0, the average, the sum, the expected value of the error term should be 0. That is the mean of the error term should be 0. And then the variance of the error term should be constant. That's the next one. The variance of the error term should be constant. So this is called homoscedasticity. If the variance of the error term is not constant, we fall into the opposite of homoscedasticity, which is heteroscedasticity. Got to drink lots of water to pronounce this word. Heteroscedasticity. All right. Everything that we are talking about from here to here, most of them are about the errors. The errors. This is another one about the errors. The errors should not be autocorrelated. In other words, they shouldn't depend on each other. The error from this observation, the one I calculated, and the error from the other observation should not influence each other. Okay, they should be not influencing each other. Another way of saying it is that they should be orthogonal. Or another way of saying is that there should be no covariance. So you can see that the covariance between error I and error J should not be 0. Okay. What have I done? It should be 0. It should be 0. What have I done? The covariance should be 0. I don't know why I do it. Not equal. It should be equal to 0. Okay. So take note. In other words, they shouldn't be related. So the variation should, or the correlation should be 0, or the covariance should be 0. There should be no correlation, no covariance. So this is again another assumption. Then this assumption is very important. Take note. Multicollinearity. Multicollinearity, write this down, guys. Multicollinearity exists because I've asked you a question on this to define it and then do some things with it. Multicollinearity exists when two independent variables are so highly correlated that it becomes difficult. It becomes hard to disentangle the partial effect. If you don't want to disentangle, you say separate. It becomes hard to separate the partial effect of one from the other. Multicollinearity exists when two independent variables are so highly correlated that it becomes hard to disentangle the partial effect of one from the other on the dependent variable, on the DV. So what does it mean? It means that you have two independent variables. Let's take this. Suppose you have blood pressure. Okay. Blood pressure is being affected by beta 1 and then let's say weight, your weight. Okay. And then beta 2, your height. Guys, do you know that when a person is growing taller, he's also expanding in body size? Are you aware? Are you guys aware? When you
Yes,
are,
sir.
yeah.
Yes.
So you are expanding. So your weight is increasing when your height is going up. So imagine that weight says that my weight is affecting my blood pressure. And then my height is also affecting my blood pressure. Let's just say that. And apparently, say that weight and height themselves are affecting each other. Height is affecting weight and weight is affecting height. We didn't know, but the two of them were dependent some way. They are independent variables. Oh. Look at the word. They are independent, and yet they are dependent on each other. We didn't know. If that is the case, then we are falling into the trap of multicollinearity. So multicollinearity is when two guys who claim that they are independent, but actually one is dependent on the other behind the scenes. We don't want that. For a regression to be good, you don't want that. So these are assumptions. These are assumptions of regression. I'm now going to go to the next thing by going through the Brukutu data set. Today, we are now going to look at the Brukutu data set properly. We have spoken a lot about it, but I want you to fill this data set. Let's assume that you are writing your project, your dissertation, and this is a title. Determinants of demand in the alcoholic beverage industry in Ghana. Impact of location, occupation, and religion. This is a wonderful title, by the way, because you must have done a lot of background research of the literature. You see, it's possible that you may have delved into the literature and you have detected that previous studies on this subject have not considered the potential effect of location and occupation. So that's what you've seen. Of course, you've justified that with a lot of references to prove your point. That yes, people are looking at determinants of demand in the alcoholic beverage, but they are not actually even thought of the fact that location and the type of your occupation can affect the demand for exploitation. So you actually did a beautiful problem statement and literature. You also argued that even though in the case of religion, it has been considered, okay, but most of the time they consider Christianity and Muslim. They don't consider Buddhism. Okay? And Buddhism is one thing that you have observed that it should be considered. So as far as to the best of your knowledge, it is something that has not been considered at all. And this is a gap you are filling in your project, in your dissertation. So you do a lot of preliminary work. We call it data pre-processing, exploratory data analysis. You gather the data, you clean the data, you collect the data, so many things. You do all of that. In fact, you would have probably even used ANOVA to do some things, but you've come to realize that majority of people don't use regression. So you want to do regression. You want to do regression. But before you do regression, you want to indicate the few things that must be done first. So you get to the methodology session, you write your beautiful methodology you're going to use. You would have written methodology on hypothesis testing. You would have written some methodology on correlation. And then you would have written some mathematical methodology on regression. Cool. Now you are ready to dig. So look here, I've just indicated that from the gaps, you have stated your contribution, you have stated your objectives. You're on top of your game. You have written your research questions. You have critically reviewed both the theoretical and empirical literature. See, some of these things I mentioned might not be important now, but next year you see that they will all be important. In fact, you might even have drawn a conceptual framework. You would have done a sketch, conceptual framework of your whole work. And you're on top of your game. Okay. You would have dug into some theories, maybe property rights theory, maybe theories related to agency, maybe theories on stakeholder theory, maybe, so, you would have used some theories. And then you have also collected your data already. And your goal is to use your data you've collected to address the questions or the hypothesis you have posed in your introduction. Now, let's assume that the data you collected is known as the Brukutu Venture dataset. And this dataset is what we're about to talk about. You see, what your supervisor didn't know is that your Brukutu dataset was actually coming from a company manager. And the management of that company are so worried because they have been hit hard since newcomers are coming into the market. Okay? So management is very, very concerned. And management are worried that the way people are entering the market, if they don't really find out what people want with the alcoholic beverage, if they don't know the actual determinants of demand, they might be focusing on the wrong areas. And the market will be taken by the new entrants. So what they did is that they identified some predictors. These predictors are the same as the independent variables. They wanted to know how these predictors better explain the quantity demanded of gene bitters. Now, they already know that price of the gene can affect the demand. They know that. But then based on the literature, they've also gathered that other factors, such as the price of complement, such as the average real income of the customers, all of these will affect it. And this is the data set. I'll show you the data set properly. They've also realized that the location of the shop can affect. In fact, you have decided to realize that the location, let me show you something interesting. Let's go back to the actual data set. So when you look at the location, you realize that the location itself is a dummy variable. In other words, it's categorical, or better still, numerical variable. Dummy, the same thing. So because they are dummy, you decided to code them. So if a person is in an urban, if a shop, these are shops, by the way. If a shop is in an urban area, you code it as 1. But if the shop is in a rural area, you code it as 2. That is why I've come down here, and then here I've coded a shop here as location urban. So everywhere you go to location urban, 1 represents what here? This 1, it represents what? Urban. This other 1 represents what? Another urban. This 0 represents what? Rural. This 1 represents what? Urban. This 0, 0, 0, 0 represents what? Rural. So you've coded them. By the way, Excel can do this coding simple. I have done an example of that. Okay. Now, so let's go back to the original data set. You also know that occupation can affect the quantity demanded of the gene bitters. For example, if the people are teachers, fishers, traders, which of them do you think they can consume a lot of akpete, guys? Which of them can consume a lot of alcohol? Yeah.
Fishermen.
Thank you. Now, we always have a prior knowledge, but as to whether that is true, we will verify that by looking at the analysis. Let's go to religion. You also believed that looking at the literature, you come to the conclusion that religions like Muslim, Buddhism, and Christians, the type of the religion of the person can also affect the quantity demanded. Which of these religious groups do you think consume a lot of akpete? Without a shadow of a doubt. Which one?
Christians.
Christians.
Again, as to whether that is true, the data will tell us. So you have a feel of the data. If this data has some missing variables, you will clear it. If it doesn't, you proceed. Our own, there is no missing variable, so we can proceed. Guys, this is a whole research. That is a whole 3 credit hour course. Once this data is ready, there are so many things you can do with it. The first thing I want us to do here is to use the coded one here to generate a descriptive statistics. Now, normally, listen carefully because there's a question on this. Normally, and write it down, when you are doing descriptive statistics, you don't really want to look at the dummy variables or the categorical variables. Because first of all, they are static. Take note. They are static. They are not changing. They are dummies. They are statues. They are stagnant. And so you don't want to generate a descriptive statistics to indicate whether they are going up or coming down because they are static in the first place. So normally when you are doing this thing, you do it for only the numerical variables. I just want you guys to know that. So we are going to just take these numerical variables and generate a descriptive statistics for them. What do I mean by descriptive statistics? Well, there are quite a lot of them, about 10 of them. Who can give me one example of a descriptive statistics? We've done this already. So who can give me one? Summary statistics. Bridget.
Say standard deviation.
Give me another one. Give me 3.
Mode, mean, and the median.
Very good. So you got 2 marks for that. Who can give me another 3? Without mentioning the ones she said. Mean, median, mode, and then standard deviation. Apart from that, okay, you also have the variance. You have the ketosis. You have the skewness. You have the range. You have the interquartile range. You have the minimum absolute deviation. You have the trend mean, and so forth. So these are all descriptive statistics. Now I'm going to show you how to generate descriptive statistics or summary statistics using Excel. And like I said, you're going to focus on only the changing variables. So please open your data if you haven't done so. And then to do that, go to the top and click on the data tab at the top. Data tab. And follow me. By the way, let me see by hands those of you who have opened this Excel data. Let me see. I'm counting. So raise your hand and see. If you have opened this Excel data and you are following me, not that you are about to open, but you have opened. 22 people.
Hello, Doc.
Yeah.
Please, I have a question.
Yeah, go ahead.
So please, my Excel is the 2019 one. So when I open data, I can't find the data analysis there. So I want to know if maybe, perhaps if you know where I'll find it, since mine is older.
It's MacBook you are rather using, isn't it?
No, sir.
Windows.
Yes, please.
So you mean at the top here, you don't see data?
No, sir. No, I see data, but I can't find the data analysis.
Oh, don't worry. I'm about to show all of you how to find data.
All right, sir. Thank you.
Okay, so let me see the number now. All right. So for those of you who do not have data analysis on the far right, this is what you should do. Click on the file on the top left. File. Click on file. When you click on file, at the bottom far left, you see options. 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 Click on options. And then the options parameter dialog box will pop. What you see on my screen is the options parameter dialog box. Okay, please lower your hand. Then on the far left pane, you will see add-ins, add-ins, add-ins. Click on add-ins and select analysis toolpack at the bottom or at the top. Please note it's not the VBA one. It is analysis toolpack, not analysis toolpack VBA. Okay. So once you select analysis toolpack, click on it and then come down and you see go. Under manage, you see go. 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 Click on go. And then you will see the add-ins parameter dialog box will pop. In the list, you will look for analysis toolpack. There's a little box near analysis toolpack, not the VBA one. Check the box and click on it. Check the box. Just that one box. Don't go and check the others. And then click OK. You should now see data analysis at the data tab. Did it work?
Yes, sir.
Good. So now we are ready to proceed. So Click now on data analysis, everybody. You're going to show me your results right now. So if you don't go through the process, you can show me your result. Click on, you're going to take a quick form, this thing, and then you post it on the page for me. Click on data analysis within a specified time. Click on data analysis and look for D. You see descriptive statistics. Click on descriptive statistics. And the first thing you see is input range. You see that the cursor is blinking in the input range. That's okay. While the cursor is blinking there, fine. Even if it's not blinking, just click inside the white space. You see the cursor will start blinking. Once it's blinking now, you are going to click on the key, hold the key, click and hold, and drag it to the M. Okay, click, hold, drag it to the M, and drag it all the way down to the end. Once you bypass the end, come back. You should just be the last one at the end. Still hold it. And then after you see that you've done everything correctly, release your hand. The moment you release your hand, you will see inside the input range, C1 colon F41. That's what you see there, C1 colon F41. Remember, we are just focusing on the numeric variables, the numbers. Okay, now ensure to check the box that says labels in first row. Check that box. Labels in first row. You will see that a new worksheet has been created, has been selected in blue. Click on that white space to it. We are going to label our results in a new sheet. So just type summary, S-U-M-M, in small letters, in there, S-U-M-M. After that, come down and take summary statistics. Take only that box, summary statistics. Now, when we click OK, the result is going to create another sheet called SUMM. You see, right now, when you look at the bottom here, the sheets are Burkutu Excel and Burkutu R. Another sheet is going to be created once we click OK. Click OK. So you can see that another sheet has been created, and this is called SUM. You will see that the sheet will automatically be highlighted. Okay. Now, click inside it to remove the highlight. You can double click when the cursor turns black on each of the cells column. Double click to expand it, 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 double click to expand it like that. But then you are going to move the key, click on this key, drag it to the M alone, and cut it. Cut it means you can do Control X to cut. So do Control X to cut it. This was at column A. Just come to column B, first cell. So B1. Click inside column cell B1 and do paste, Control V to paste. You see, you will only shift the thing from the one cell right. You're only shifting the names. Why are we doing that? Because the word mean is appearing many times. You see, there's another mean, there's another mean, there's another mean. Okay, so we're going to delete this one. So click column C on top of the column C. Click on it. It will be highlighted and hold down the Control key. Whilst you click on E, hold down the Control key whilst you click on J. Okay. Once you've done that, right-click on either of them. Right-click on the C. Right-click on the C at the top, not in the white space, but at the top. Right-click and choose Delete. Everything will be deleted, and you see the whole thing will be cluttered together beautifully. Yes, Ruth.
So please, can you go over from when you said we should drag the kill all to the M? What was the next step after that?
Once you have the Q like this, you copy all of you highlight all of this, cut it, that is Control X to cut it. Then click on the B1, Control V to paste. Once you're done with that, you're about to remove these columns because they are repetitive. So you click on C column, you hold the Control key down, you click on E column, you hold the Control key down, don't remove your hand from the Control key. And then you click on G column. And then once you are done, you can right click on the C column, on top of the C itself. Now right click on the C itself and choose delete. It will delete all of these things and you will see that the numbers will be beautifully cluttered. So you will see that the Q, the P, the C, the M, all of them will have their means. As you can see, this is a mean, this is a standard error, this is a median, the mode, the standard deviation. These are the summary statistics we spoke about. You have the ketosis, the skewness, the range, the minimum value, the maximum value, the sum, and finally the sample size, which is called the count. Count. What have we done? What have we just done? We just created a summary statistics of this whole Brukutu data set. What for? What for? It is for something beautiful. You see, now we know that the quantity demanded, the mean quantity demanded, the bottles of quantity demanded is 175 for this industry, for this Brukutu company. We also know that the median is also 75. So the mean is 75. I can choose to highlight that. The median is 75. The mode is 160. You know what that means? If you have the mean and the median being the same, maybe the data is normally distributed. But that is when the mode is also 175. But unfortunately, the mode is not 175. So you are able to talk about overall. You are talking in terms of generalization when you look at it. Another thing that is interesting to look at is the standard deviation, this one. The standard deviation tells you how far away the other guys are from the mean. And this one we see here is 29.78, which is approximately 30. So it means that the data points are on average 30 standard deviation away from the mean, from the center. But here's something I want you to think about, and you want to take note. When the standard deviation is more than the mean, it means that most of the observations have bigger sizes and some of them are of smaller sizes. When the standard deviation is more than the mean, it means that some of the observations are so big. In this case, if we are talking about quantity demanded, okay, if the standard deviation was more than the mean, right now the mean is 175, but the standard deviation is 29.78. If the standard deviation was like 200, then it means that some of the quantity demanded, the bottles of quantity demanded, some of them are very large bottles, some of them are very small bottles. And that is why the standard deviation is big like that. But when the standard deviation is smaller than the mean, it means that they are similar sizes. Similar sizes. It means that that particular column, the variables are of similar size. Now, what do you think if the standard deviation is 0? Who can tell me? What do you think if the standard deviation is 0? Go and think about it before you see it somewhere. If the standard deviation is 0, what does that imply? What does that imply? All right. So this is a bit of information I want you to take note on this. Another thing you can do with this data set is in Excel, still in Excel. Today, I'm just going to show you in Excel. Okay, let me just leave the rest and then go and show you how to do this in R. Have you opened your R? By the way, raise your hand if you have opened your R Studio. Let me see whether some of you have already opened it. Raise your hand if you have already, not that you're about to open, but you have already opened your R Studio. Oh, great. Okay, once you've opened it, it means you have to do something. So what we just did, let's just do it in R Studio. So I'm going to open my R Studio here. Let's go to Brukutu. So I want you to go to your R Studio. I'm going to just create a new sheet. In fact, when you go to your R Studio, you will notice that you have an empty slot like this. Okay. You have an empty slot, very empty. If you don't have that, let me know. Some of you will have the one from the ANOVA rather open, so you wouldn't have empty slot like this. You can lower your hands. So in this, we are going to read the data set. And I think last time we read it. So you know how to read the data set. Just type, and by the way, this is all in your notes, so you can check your slides later. Just type GIN. In fact, let me show you in the slides so that in case you don't follow, it's here. Everything I'm doing is here. Okay. So you're going to type GIN read.delim, blah, 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 blah. You can copy it, but you have to be careful when you paste it into the R. This is a command. Okay. So you can come here, and I like you to rather type it. Whenever you paste it, you have to check that there is no red dot. Because whenever there's a red dot, it means there's a mistake. You have to check. Okay, so you can copy. So what is the GIN? GIN here is the name of the data set, how we called it. And I've explained it all in the slides. So when you check the slides, it says that anytime you see the hash symbol, what follows is that it is giving you an instruction of what you have written on the left mean. Okay. Now, so let's load the data. This is the command that is going to load the data. How do you load the data? Go to your Excel and then choose the Brukutu R. This is a data set. Copy the entire data set. If you click inside and do Control A, just click anywhere inside this and do Control A, it will highlight everything. Do Control C, it will copy everything. Some of you like dragging too much. Sometimes learn to use Control. Okay, so once you have copied it, go to your R Studio. Don't paste it, don't paste it. Click anywhere here in your command and run it. You don't paste, you run it at the top. You run, you don't paste, you run. So click run, and the moment you click run at the bottom, you see the name of the data set in blue, which means that the data has been loaded. If you want to see it, just highlight only the GIN, the GIN. Highlight only that one and run it. Another way of running is just doing Control Enter. So you don't need to always go and click run at the top. Okay, you can do Control Enter. And then you see at the bottom, the data will all be showing down here. You are done, which means that the data is loaded. Let's say you want only the top part of the data. Let's say this data is 50,000 and you don't want to see all of it, but you just want the top part. You can just write head, H-E-A-D, okay. Head. And then after writing the head, inside the bracket, you type the name of the data, GIN. And once you do that, okay, it will just show you just the first 5 rows. First 6 rows. And you see the first 6 rows. If you want an instruction so that you remember what you wrote, bring the hash symbol and just type, anything you like. Just type something like, it tells me the first 6 rows. Or sometimes you just say first 6 rows. And if you want the bottom 6, you can write tail and write the name of the data set in the bracket. It will also give you the bottom last, the last 6 rows. And you know that the shops are 40 shops. So you can see that this one at the bottom is showing you the last 40, the last 6 rows. Okay. And you get them. Okay, so that's the first thing. Now the data is loaded into R Studio. What is the next thing? Well, when you go here, you can now generate summary. The summary you wanted to generate, you can generate that by typing summary into bracket, the name of the data. So let's do that. Type summary into bracket, the name of the data, and run it. When you type that, it will give you a summary of every variable. Okay, the Q, the P, the C, and all of that, it will give you. But remember that it will not give you the categorical variables. You see the categorical variables, it didn't give you the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. It didn't give you like it did for the others. If you take, for example, location, it didn't give you. The occupation, it didn't give you. Who can tell me why? Why is it that it's not giving us the summary statistics of these things? Let me see the smartest person here. Why is it that it's not giving us the summary for location, occupation, and religion, like it has done for quantity, price, and Bara?
I think you said that it's because they are dummies and they don't change.
Exactly. You get these things in your exams. So it's very important to recognize that. Okay, so let's look at the ones that are not dummies, the ones that are numeric. It gives us only the minimum value, the maximum value, the median, and the mean. We don't even have standard deviation. We don't have standard deviation. Like Excel even gave us more things, if you can remember. The Excel we did here, it gave us more things. But this one is not giving us a lot of things. But that is because the summary command you used here is not enough. It's not enough, guys. In your assignment, you do all of these and more. So that's why it's important you are clear. So the summary is not enough, guys. We need something that will give us more summary. And to do that, you go and require this package. A package. So you need a package. Now, what is a package? A package is like some instrument you need to be able to execute some commands. You need some fuel to be able to do the driving. There's a particular kind of instrument, a particular kind of package. So it is something you need to do some work. And it depends on the work, then you will get a package. Now, this package is called Psych, and we will need to install it if we haven't done it. So first of all, we don't have the package. Most of you don't have it. I have, but you don't have. So first, we need to install it using the internet. So on the bottom right, look on the far bottom right here. Far bottom right. Do you see packages as one of
Yes.
the? Good. Click on packages and click on install. click on packages, click on install. The parameter for install packages will pop. And this is where you will type your site. So type your site. P S. I didn't write it. Site. PSYCH. See, as you start typing, your internet will start bringing them up. I think is the first one. This one. So again, you need to type that. Then you can. So what you do is that once it comes, just select it and click install. Install. And once you start, I have installed already, so I don't want to install. Once you are installing, you see some red something, red symbol going up and down here. You see some red round thing going up and down here, going round, blinking and coming, which means it is installing, so don't interrupt it. It's installing, don't interrupt it. Is somebody installing? If you are installing, let me see. Let me see by hand. If you are installing, because not many people will install, so I want to see those who install. Only Root is installed, and Emma.
No, please, my hand is raised because I wanted to ask a question.
Okay.
Please, I've clicked on the install, but I can't see any red thing going around on my screen.
It is a pop-up that will pop.
I'm not also seeing anything.
Okay, no problem. If you're not seeing anything, come down. You will see that the word install has popped, has shown in the console down here. Do you see anything written like that? Down here, you must see something like install in blue. Do you see anything like that in the main console down here?
I see install packages in bracket psych.
Is it blue or red?
It's blue, but it's at the top.
At the top where?
After where they've written console, terminal, background jobs.
Oh yeah, but it's the last thing on that screen, isn't it? It's the last thing. It's the last.
Beneath it, there's a warning. Warning, R2 is
That's what
required.
I mean. It's the last thing, and then there's a warning.
Oh, okay.
Yeah, but the way you said it's at the top, it's like there's so many things below it. Yeah, it's okay. So that means that your this thing is installed. Now, for us to be sure that it's installed, come and type this command here. Type require site. This one. Type this and run it. When you type and you run it, tell me what shows down here. You should see loading require package. If you don't see loading require package, you let me know. By the way, if you don't see that round thing going, it has installed quickly. It means your internet is fast. So type the require site and run it. And let me know whether at the bottom you see loading require package. Who has been able to do and has the loading require package? Solomon, Terence, who else? Judy. Bridget. Okay. Great. So now it means that you have been able to go through all that you have done. So that's all we need. Now type describe. Type describe. You see the describe sign will come. The word will come. And click on the word. Sometimes when you are typing and the word pops, select one. So this is describe. Click on the describe. And then bracket, you see the bracket will come. Describe. Inside the bracket, type GIN. Type GIN, the name of our data set. Type GIN. And then after that, run it. Run it. And when you do that, you should get something like what I have down here. You should get something beautiful like what I have down here. It's a whole descriptive statistics with many things. Do you have it? Who has it? Solomon has it. Who else? Terence has. Olivia has. Bridget has. Manuela has. So these guys are the ones working along with me. So you can see that in this R is a very sensible package, software. You can see that it has made some of the words with stars. Okay, if you look down here, some of the words are stars, but some of them don't have stars. They don't have stars, but others have got stars. What do you think is the reason why some have stars and others don't have stars? Bridget.
So I think it's from the points Barbara made earlier on that the location, occupation, and religion are the dummies.
So because they are categorical dummies, that is why R recognizes that. So, and yet R has given you their values. So it's telling you that even though I'm giving you their values, don't rely on them. Because you don't need numerical values for categorical elements. You cannot find the mean of location. It's useless. Location is either urban or rural. You can't find the mean of that. So it's telling you, don't focus on them. That's it. Take note. Okay. And you can see that now you have the mean, you have the standard deviation, the median, the trend, the minimum absolute deviation, the minimum, the maximum, the range, the skewness, the ketosis, the standard error. So you have all the necessary things you need to have. You have it there. So this gives you more descriptive statistics that you can be asked questions related to. Like, my exams have asked these questions. So take note of. Okay. So this is how you join. I can ask you that what is the mean of the quantity demanded here? In fact, I want somebody to tell me this. What is the It's interesting. What is the range for quantity demanded? Who can tell us? What is the range of quantity demanded? Babigo.
I think it's 90.
It is 90. It is 90. That's a range.
Okay.
So you should know what each one of them is and then what they mean. Know what it is, know what it means. Know what it is, know what it means. Know what it is, know what it means. Okay? It's very, very crucial you know what it is. Now, it's not only described by, it's not only describe you can do. Okay. Oh, by the way, if you look at these questions, it's interesting. What is the sample size here? What is the sample size? Looking at the results, what is the sample size? Looking at the described results. Terence. Terence.
Yes, 40.
Okay. So you can see that at the column for the N for all of them. So take note. Okay. You can also do certain things like describe by. Okay, describe by. I'll tell you why describe by is interesting. Let's say that. Okay, so I'm going back here. So type this. Type describe by. As you are typing describe by, use the by, the one that is capital. Yeah, describe by. And then type the name of the data. Bring a comma. Type the name of the data. Bring a comma. Type group. And then you see the group will come with an equal to. And then do single apostrophe. And inside the single apostrophe, type REL. REL is for religion. Religion. Now, what are we doing? What you are doing here is that you want the software R to give you the descriptive statistics for each religion. You see, right now, the one you're having here is for all the 40 observations. But it's like you want the descriptive statistics for only Christians, for only Muslims, and for only Buddhists. So you want it to give you the average quantity demanded for each one of them, the median, price for each one of them. You want this same descriptive statistics you see down here. You want it for every one of them, but according to the groups. Okay. So with this, run it. Let's see. Run yours, and you'll get something like I have here. So you can see that the first one is religion 1. I don't know why R is calling it religion 1. Okay. He's calling it religion 1, religion 2, religion 3. Okay. Now, whilst this is okay, it doesn't really tell you the actual name of the religion. Okay. So it's not really a very nice one to choose. So let's use another one. Okay. So let's rather type describe by. So you can copy the first one and dump it here. Copy and paste it. But inside the bracket, choose the same religion, rather make it like we have here, Jin. After the Jin, you bring a comma and do Jin dollar religion, REL. And let's run that. You see, I like that one because that one will mention the name of the religion. So you can see that for Buddhists, how many people are there? Look at the N column. Buddhists are 12 shops. So there are 12 shops that are in the Buddhist area. And then you have Christians. There are also 12 shops that are in the Christian area. But when you look at Muslims, there are 16 shops that are in the blah, blah, blah. And for each shop, you can get the mean. So the quantity demanded, the average quantity demanded among the Muslim is 147. The average quantity demanded among the Christian is 206. That's the average. And then the average or the mean quantity demanded among the Buddhists is 180. So looking at the mean, which of them do you think is consuming a lot of akpatation? Which of them? Looking at the quantity demanded for the religious groups, the average quantity demanded, which of them is consuming a lot of gin?
I think the Christians.
The Christians. Because when you look at the Christians, theirs is what, 206. We are consuming a lot. So evidences are coming. Evidences are coming clearly. When we draw the graph too, it can show that. Okay. What I'm going to do is I'm going to pause here. I'm going to stop here. Next time, we are going to continue. So we've done descriptive statistics, both in Excel as well as in R. Go and play with the rest, okay? Go and play. Everything I've done here is in your slides. But go and play with the rest. Okay? Some of the graphs and all of that, go and play with it and all of that. Because this thing will show you. Next time, we are going to look at how to do this correlation and then continue the rest of the information and address some questions in correlation. That's what we are going to do with this data set, because we have generated a correlation in Excel, but we have not started talking about the correlation. So we'll talk about the correlation next time. We'll do it both in Excel and R, and then we'll talk about the correlation. But there are a few things I want you to go and do. I want you to go and learn how to generate the following. These graphs, all of these graphs, and their meanings, go and learn them before next time. Ladies and gentlemen, that brings us to the end of the entire caboodle. Now, Richard, do you have a question?
Yes, Doc, I want to find out from you that can you help those of us using MacBooks, because it looks like, you know, the proceedings, you were struggling quite a bit. So do you have videos on the people using MacBook, or is it just all Windows?
I have some videos on that. So I think you should type the word MacBook. But it depends on what you want to do. Because the foundation is that once you get to know that you have to install that X11 something something, and once you install that X11 something something, the rest will follow this one. Isn't it? You are being asked to do that, right?
Yes, but it didn't quite work out. So
yeah, so you just type that into the YouTube channel, and then you see how you can navigate around that installation process, because that is the only thing you need to do, and then everything you level the playing field. So you try it first using the YouTube channel, and then if you don't get it, you let me know.
Okay, Doc. Thank you so much.
All right. Guys, there will be one assignment on all these. Just one group assignment. It's detailed. That is why it's important that you are learning to do this so that you succeed in the group work. All right.